What if I told you that time doesn't pass the same for everyone? That gravity isn't a force pulling objects together, but a curve in the fabric of the universe itself? Sounds like science fiction, right? But it's not. It's the mind-blowing reality of Albert Einstein's theory of relativity, a concept that completely rewrote the laws of physics and changed how we understand the universe. In today's video, we'll unravel the mysteries of this groundbreaking theory, explore how it impacts everything from black holes to GPS navigation, and answer questions like, what would happen if the sun disappeared? Trust me, you don't want to miss this. Before we dive in, make sure to hit that like button, subscribe to the channel, and turn on notifications so you don't miss any of our future videos on fascinating topics like this one. Let's jump in. Let's start with one of Einstein's groundbreaking ideas, a new way of thinking about gravity. To understand Einstein's theory of relativity, we need to start with the man who came before him, Isaac Newton. Newton described gravity as a force of attraction between two objects. The bigger the object, the stronger the pull. This idea explained everything from why we stay grounded on Earth to how planets orbit the sun. But there was a problem. Imagine if the sun suddenly vanished. According to Newton's laws, the planets would instantly fly out of their orbits. But Einstein realized this didn't make sense. How could the effects of gravity act faster than the speed of light, the universe's ultimate speed limit? Enter Einstein's revolutionary idea. He proposed that gravity isn't a force at all. Instead, massive objects like the sun warp the fabric of space and time, or space-time. Picture a trampoline with a bowling ball in the center. The ball creates a dip, and smaller objects roll towards it. This curvature of space-time is what we experience as gravity. Here's the kicker. This new way of thinking didn't just explain gravity, it opened up an entirely new understanding of how the universe works. Now let's explore the connection between the speed of light and time dilation. Did you know that time isn't fixed? It's relative. Einstein's theory showed that the closer you travel to the speed of light, the slower time passes for you. This concept is called time dilation, and it's one of the most fascinating aspects of Einstein's work. Here's an example. Imagine two twins, Alice and Bob. Alice stays on Earth while Bob embarks on a journey through space, traveling at nearly the speed of light. When Bob finally returns home, he'll have aged less than Alice. Essentially, Bob has traveled into the future compared to his twin. This thought experiment, often called the twin paradox, might sound like something out of a sci-fi movie, but it's a very real implication of Einstein's equations. In fact, astronauts aboard the International Space Station experience a tiny version of time dilation every single day. Because they're orbiting Earth at incredible speeds, their clocks tick ever so slightly slower than ours on the ground. Over the course of a year, this amounts to just a fraction of a second, but it's a measurable difference, and it proves that time dilation isn't just theoretical. But here's where it gets even more mind-bending. Time dilation doesn't just depend on speed. It also happens in the presence of massive objects like planets, stars, or black holes. The stronger the gravitational field, the slower time moves. So, if you were to stand near a black hole's event horizon, time would stretch to an almost unimaginable degree compared to someone far away in space. Think about it. Time, something we experience constantly and take for granted, is not a universal constant. It can bend and stretch, depending on speed and gravity. Have you ever thought about what you'd do if you could time travel like that? Would you visit the future, or maybe even return to the past? Let me know in the comments. I'd love to hear your ideas. Next, let's dive into the fascinating concept of gravitational waves, those incredible ripples that travel across the fabric of space-time. Einstein's work didn't stop with space-time curvature. He also predicted something incredible: gravitational waves. These are ripples in space-time caused by massive cosmic events, like two black holes colliding. Think of them as the ripples you see when you drop a stone into a pond, but on a cosmic scale. For decades, gravitational waves were just a theoretical idea. But in 2015, scientists detected them for the first time using the LIGO observatory. This groundbreaking discovery proved Einstein right once again and opened a whole new window into observing the universe. Fun fact, Without Einstein's theories, technologies like LIGO and even your smartphone's GPS wouldn't work properly. That's right. The next time you're navigating to your favorite coffee shop, you can thank Einstein. Now, let's revisit the question from earlier. What would happen if the sun suddenly vanished? According to Einstein's theory of relativity, the effects wouldn't be instant. The sun's disappearance would send a ripple, a gravitational wave, through the fabric of space-time, traveling at the speed of light. Since light takes about 8 minutes to travel from the sun to Earth, we'd continue to orbit as though the sun was still there for those 8 minutes. At that exact moment, we'd see the sun go dark and simultaneously feel the loss of its gravitational pull. This thought experiment does more than spark curiosity. It highlights the profound insight Einstein's theory provides into the mechanics of the universe. Gravity, as Einstein showed, isn't a force that acts instantly across space, as Newton once believed. Instead, it's the result of space-time curvature, and any disturbance to that curvature takes time to propagate. Isn't it incredible to think that even in such a catastrophic scenario, relativity helps us predict exactly what would happen? It's a reminder of just how interconnected light, gravity, and space-time truly are. Next, we step into the strange world of black holes. Black holes are perhaps the most mind-bending consequence of general relativity. These are regions where space-time curves so much that not even light can escape. Essentially, they're like cosmic trapdoors. Here's a cool analogy. Imagine trying to climb out of a steep, slippery well. If the well is deep enough, you'll never make it out. That's what happens to light near a black hole. And near the center of a black hole, space-time becomes infinitely curved, a phenomenon called a singularity. Oh, and did you know there's an opposite to black holes? They're called white holes, where nothing can enter. While black holes are well documented, white holes remain purely theoretical. This opens up exciting possibilities for future research. Lastly, let's understand the connection between the theory of relativity and our everyday life. You might be wondering, why should I care about relativity? Well, it's not just for scientists studying the cosmos. Einstein's theory impacts our daily lives. Take GPS satellites, for example. They orbit Earth at high speeds and experience weaker gravity compared to us. These factors cause their clocks to tick faster than those on the ground. Engineers have to adjust for this time difference using Einstein's equations. Without these corrections, GPS systems would be wildly inaccurate. But it doesn't stop there. Relativity also plays a role in advanced technologies, like particle accelerators, which help scientists study the building blocks of the universe. Even theories about time travel in science fiction owe their roots to Einstein's ideas. So, the next time you find your way home using maps, or watch a sci-fi movie about bending time, give a little nod to Einstein. His work is quite literally guiding you and inspiring generations of thinkers and dreamers. To wrap things up, Einstein's theory of relativity didn't just change physics, it changed our entire understanding of the universe. From bending space-time to predicting gravitational waves, his ideas continue to inspire new discoveries and innovations over a century later. And while his theories might seem abstract, they're woven into the fabric of our daily lives, shaping the technology we rely on and the way we view the cosmos. What part of Einstein's theory fascinated you the most? Let me know in the comments below. And if you enjoyed this journey into the mysteries of the universe, make sure to like this video, share it with your friends, and subscribe to the channel for more fascinating content. Don't forget to turn on notifications so you never miss a new video. Thanks for watching.